Welcome to this Java break with Basis. Today's topic is writing your web app in the latest BBX. My name is Nico Spence. I'm the Chairman and CEO of Basis International. And today I'm going to be joined by Nick Decker, our Engineering Supervisor, who will be showing us more about part 2 of our two-part series of applying the lessons learned of how to write your web app in the latest BBX. We'll look specifically at areas like optimizations, and these will apply equally well to your web app as well as your thin client deployment. And Nick will take us through utilizing cascading style sheets. We'll look at a few editors and a few examples. And there in particular, we'll look at some sample code of generating a login screen. And we'll make that code available to you at the end of today's session. So let's look at the agenda. Firstly, I'll do a quick recap of the first part. And then we'll look at retrofitting the optimizations we learnt from part 1. And we'll apply those to the Bowie Mortgage amortization app that we ship with our product. If you check the box for demos, you'll get the source code. Then we'll look at cascading style sheets, CSS. We'll look at several editors, and then we'll take you through the example code of our login screen and how we apply CSS utilizing a couple of the editors that we mentioned. And then we'll give you a summary and finish off with your questions. So let's have a quick recap of what we covered last week. Our challenge was that we needed to rewrite our download page on our website to take advantage of new functionality that our users have requested, as well as to integrate with our production system. We had a couple of choices. We could stay with the old, utilize the old tools, the plethora of third-party programming languages and databases, or we could choose to use the Basis product set. So we went from using HTML, Perl, and JavaScript and narrowed that down just to using BBJ. We then covered the execution, how we optimized the code, how we delivered it to mobile platforms, and how we provided localization, delivering the solution in 5 languages. And then we covered the benefits. So this is what the download page looked like before, a pretty long page that required you to scroll, had a multiplicity of selection choices, more information about the user than we probably needed. And we narrowed that down to essentially one page, and we wrote that all in BBJ. We also made it available in multiple languages, as I said earlier, and we simplified the implementation. For example, utilized web services to check export compliancy rather than have to construct the SOAP envelope with a lot of additional coding effort. We also gave you the ability to download to a mobile device. You may ask, why would I want to do that? Well, that puts it into a repository that you can take wherever you go. So you go to a client site and you could move it from your cloud repository to your on-site installation. And we looked at a website called Detect Mobile Browsers, which provided some sample source code in 15 languages that we could use in our web page to eliminate the trappings of the prior web page to fit into our smaller form factor of our mobile device. What were the benefits we gained? We had a single programming language syntax. For example, it's very easy to get confused when programming in different languages when the not equal to sign may be the same for only a portion of the implementation in the language. With Perl and JavaScript, for example, in the one case it applies to both strings and numerics. In the other case, we actually have to use the NE syntax to compare strings. We ended up with a far more robust application, less prone to breakage, fewer moving parts, just one language to look after. Very much more simple and inexpensive to test and debug. BBJ ships with a built-in Jetty web server, and our QA staff could download the code or bring it out of the source code repository and test it on their own machines, and very simply invoke it and test it from a cloud-based server where they would have installed the BBJ product. So easy to enhance, one is able to embed production system business logic and directly access production system data. So let's take the lessons learned from our download page, retrofit that to the Bowie Mortgage app. We're going to look at changing that code to take advantage of the form validation event and the enhancements that we put in place to reduce round trips. Let me hand you over to Nick to take you through the nitty-gritty and see what the results were of retrofitting those optimizations to our Bowie Mortgage app.
After form validation was available for Bowie programs, we decided to put it to the test in various distributed environments. Our test program was the Bowie Mortgage demo, which was a perfect test case. It mimicked a real-world application, but due to its smaller size and reduced complexity, it was easily manageable. The Bowie mortgage program, shown here, is a souped-up version of the old _mort program, shown here. Although the Bowie version looks a lot different, we reuse some of the calculation code from the old _mort utility. However, the BBJ version is formatted a bit differently so that it's easier to read. There are no line numbers, if-then structures can span multiple lines, and you can even use mixed case. When running the mortgage program, the user starts off by entering the data values into the various fields, such as the principal amount, percentage down, etc. These values are required for the program to calculate the monthly payments. So after the user presses the Calculate button, the program retrieves the numerical values from the client's computer. In a distributed environment, where the server and client reside on different machines, network overhead and latency determine how quickly the program can retrieve the information. Our test case used two different versions of the mortgage program. The older version that retrieves the contents of the controls by querying the controls directly, and the new version that uses form validation and retrieves the contents from the BBJ form validation event directly. Because the program gets the information from the event rather than the controls, it doesn't have to communicate with the client and avoids all of the networking overhead. Our first test compared the pre- and post-validation versions with the client in Albuquerque, New Mexico, and the server on the West Coast in California. With an average ping time of 45 milliseconds, it took 3/4 of a second to retrieve the contents of the 7 input controls using the old version of the program. In contrast, the new version, which uses form validation, retrieved the same information more than 10 times faster, bypassing the round trips to the client and retrieving all the information in only 68 milliseconds. Our second test was similar, except that this time the server was located in Ireland, approximately 4,700 miles away from the client. Ping times increased to 188 milliseconds, which were significantly higher, as we expected, due to the longer distance. This increased latency made form validation even more critical, and the new version of the mortgage program was now more than 20 times faster. The total time to retrieve the field values dropped from 1,796 milliseconds down to a scant 84 milliseconds. You'd think that such a big win in performance would have a cost. After all, we did have to change code in the mortgage program to take advantage of the new Bowie form validation. However, we changed a lot less code than you'd think, and even the lines of code that we did modify, we didn't have to change them much. Here's a look at the differences in the two versions using the Basis IDE's diff functionality. The first change was to the process events, as the Calculate button now responds to a form validation event rather than a regular old push button event. Next, the new version has some extra code shown in green, where the program retrieves the form validation event that contains the information for all of the controls on the form. The next few diffs make up most of the changes. The program used to set variables by getting the values from the controls on the form. Now, the new version sets the variables by getting their values from the validation event, passing in the control as the key. So even though the lines have changed, the syntax is very similar. Lastly, the new version accepts the validation event, unlocking the form so that the user can change it once again. So overall, the changes were fairly limited and were pretty easy to make. And those changes were definitely worth it, as the calculation routine is now noticeably faster.
Thanks, Nick. This graph is really very telling. Even our example here with a 45 millisecond latency between our offices in Albuquerque and the server in California, we see this huge performance gain, going from over 150 milliseconds to begin with to just over 50 milliseconds. And you should see similar results in your own thin client deployment over a similar type of latency environment. In addition to the optimizations in the language, there are other optimizations we can take advantage of in terms of image performance. We can select the best image format, i.e. is it JPEG for photos versus PNG for kind of graphics images. And we can apply compression to those images. So utilizing open source tools like PingCrush, we can compress the PNGs. In our Bowie Mortgage app, for example, we changed the background image to a .png from a .jpeg. we applied the ping crush compression algorithm, and we decreased the size by 400% from 7.6 kilobytes to 1.9 kilobytes. Furthermore, we could also combine images with CSS sprites, and that can reduce your HTTP requests and shrink the image size. In some samples, you've seen HTTP requests reduced by tenfold. Here's an example of some of the other toolbar images that we used the ping compression algorithm against, and you can see we had substantial savings in the size of the images that would have to be transmitted across those high latency lines. We can also implement CSS sprites, as I said earlier, and they're third-party tools that allow us to do that and generate the code for us. So again, a lot of the heavy lifting is done on your behalf. Now let me hand over to Nick to take us through the sample buoy login application. We're going to take you from an application that looks like this, much like you might expect from raw BBJ code, to one that looks like this, something that really is significantly enhanced by the application of CSS. Now we are going to look at various CSS editors. There's one built into the Basis IDE, and there are others that handle things like generating gradients for us, some other stylized third-party tools, but we're going to focus today by looking at the Espresso CSS editor tool. So let me hand over to Nick to take you through the process.
In order to familiarize ourselves with some of the neat CSS capabilities supported by BBJ buoy apps, we're going to take an inside peek at the development cycle of a small application that is responsible for authenticating users. The app was written in the Basis IDE. It runs in both SysGUI and buoy and utilizes a resource that was built in Form Builder. Here's what the app looks like. It's comprised of a single login window. The form utilizes a few different types of controls: static text controls for labels, edit boxes for user input, and buttons to log in or exit. The program source is fairly simple. It opens up the resource, assigns the controls on the window to BBJ objects, registers for events, and begins processing user input. The program uses the BBJ form validation paradigm and also utilizes cookies to save the user's account information. The login subroutine executes when the login button is pressed, and the code retrieves the control information from the event. After saving out the user account into a cookie, it will either accept or deny the validation event based on whether a password was provided or not. We can run it in SysGUI to get an idea of what the program looks and acts like. Because we want to run it in buoy and define our own CSS, the next step is to register the program as a buoy app in Enterprise Manager. Although you have many options, only a few of the fields are required, such as the program to run. Right-clicking on the provided URL and selecting Launch executes the program in our default browser. Now, on to the fun part, experimenting with CSS. There are many CSS editors available, and the Basis IDE also doubles as a solid CSS editor with syntax coloring. For this exercise, I'll be using a third-party app that has a few nice features, such as auto-completion, a toolbar mode that writes the CSS code for you, and the ability to view changes in real time without having to relaunch your buoy app. There's a lot of CSS in the source file, and the syntax may look a bit odd at first, but we'll soon see that we don't absolutely need a thorough understanding of CSS in order to make progress. The first section primarily deals with some global settings, and the body selector here is the first interesting part. It defines the outer HTML, the part of the web page that surrounds our buoy application. Instead of a plain, boring white background, we have an image defined instead. This is a copy of Apple's famous linen texture, and we set the image to repeat so that it's tiled and fills the entire browser window. Uncommenting the line causes the background property to instantly take effect on the wrapper portion of the web page. The next point of interest is a definition for a custom font. We're using free fonts from Google, and the recent CSS capability that allows you to utilize custom fonts without having to install them on the client's machine. They're downloaded and used by the client's browser automatically so that your web page looks great. Google offers over 500 free fonts, and you can browse the fonts and filter by family, thickness, etc. It also has various viewing options for the preview of text and sorting, making it fun to find a stylish font. The next section is our pseudo title, which is really just a styled static text control. In order to give it some flair, we'll define its background via a CSS gradient. After heading over to ColorZilla's gradient editor, we can browse dozens of predefined gradients, create, modify, and save our own designs, or even import gradients from existing CSS or images. We can select the sample gradient, copy the definition into our clipboard, and then paste it into our custom CSS file. The result is displayed in our Buoy app so we can see what it looks like right away. This site is great, as gradients are a prime example of one of CSS's current hassles: vendor prefixes. Browser vendors such as Mozilla or Opera have implemented their own format for some properties like gradients. Until an official format makes it into the specification, we must include all of the various formats if we want the gradient to work on each kind of browser. This is another reason that utilities like this one are so important. They turn a job like memorizing vendor prefix formats, which is virtually impossible, into a simple copy-paste operation. After uncommenting our real definition, the next step is to round the bottom corners, but leave the top corners intact. Again, we're dealing with vendor prefixes, but another website is just a click away and makes the job easy. The border radius site helps us define the properties quickly. And with one more copy and paste, we've got our rounded bottom corners. We're almost done with the title. All that's left is changing the text. The color is all wrong, as both the text and the background gradient are dark, making it almost impossible to read. We solve this by setting the font color to white. The next few properties further define the text, including the last one that sets the font family to our custom font that we downloaded earlier from Google. Our title is now complete, so now we'll modify the user and password controls. Notice the padding left option. With this parameter, we're specifying that the contents of the edit box, the text within the edit box, should be pushed over to the right to make room for a padding area of 22 pixels. Toggling that line shows the text position changing, and we want it further over to make room for an image that will sit in the background of the edit box control. The background parameters add useful icons to the edit boxes, and the extra left padding ensures that the text will not overlap the image. Now for something a little tricky. We start by making the main window invisible, which is accomplished by setting the background color to transparent. Our BBJ window disappears, and now you can see the controls sitting directly on the linen texture. Note that this is different than modifying the opacity of the window. By setting the opacity to 0, the window and the controls disappear. Setting the opacity to 0.5 makes everything partially transparent, but our goal is to only affect the window, not all of the controls on the window. The next part of the trick is to define the appearance of a static text control that's just a bit smaller than the full window. Setting its background color makes it suddenly appear. Setting our old friend, the border radius, takes away the sharp rectangular corners of the control. The last change to the window relies on the box shadow property. We'll use this 3 different ways, as some CSS properties, like this one, can be defined multiple times in an additive fashion. The first shadow is inset, meaning that it is inside the control instead of outside of the control. We'll shift it up and make it white so that it provides a rounded top edge to the form. The next shadow is shifted below the form and is not fuzzy at all, so that it appears as though the window has a 3D bottom edge. The last shadow defines our final dark drop shadow, making the form appear as though it's floating above the linen texture. Turning them all on at once gives us the final 3D look that we were shooting for. This is a good point to stop and take a look at some of the other things that CSS tools can do for you. Instead of modifying the code directly, we can show the toolbar and interactively start changing various properties. such as the color of the shadow, the level of transparency, the shadow size, X and Y offsets, etc. The tool helps us define other types of CSS too, like text-specific properties for setting color, size, style, variations, etc. The interface is similar to Microsoft Word's Toolbar, so it's easy to use, and you don't have to remember any of the CSS properties. Our final customization deals with the buttons. By uncommenting the code, we can see the final versions of our buttons, complete with hover effects, focus indicators, and even special coloring for the default button on the form. Our buoy app is now complete. It runs in both SysGUI and buoy, and we've added tons of customizations to the web-based version by leveraging custom CSS. Leaning heavily on smart editors and helper websites, we've created an artistic-looking login form to be used later for an upcoming web portal project.
Thanks, Nick. So a really great example of the enhancements that CSS will bring to your web-based application. So one of the questions that we have fielded over the last couple of weeks is, can we take advantage of the Retina display? And the answer is certainly you can. So here's an example of it, whereby we can utilize CSS to enhance the number of pixels delivered on the image. So by determining whether we are on a Retina type display, we can quadruple the resolution of the image that we generate for Retina displays. Now, Nick showed you earlier how we can go into the Enterprise Manager and do our buoy configuration. I wanted to point out in a bit more detail, the only two fields that are required is the name of your buoy app and the actual program name. But beyond that, CSS is optional, and you'll see down here that we also have the ability to put the shortcut icon. That's the icon that appears in the top left-hand corner next to your URL. So we utilize the same icon that we had in the password field to actually show up in the top left corner. So pretty straightforward, and we really encourage you to go ahead and try running your GUI apps in the browser user interface. Simply come into the buoy configuration, give it the name of your program, and then you can right-click on the URL and launch it in your local browser. In summary, what have we covered in applying the lessons today? We've looked at a quick recap of the first part of our series. Then we looked at retrofitting those optimizations to the buoy mortgage app. We also then looked into more detail on a sample program, a login program of how to apply cascading style sheets. We looked at several editors and we showed you the example code. Just a quick reminder, if you want to see the sample code in action, you can either go to our showcase, go to web apps, and there you can run the various applications like the buoy mortgage amortization app. You can run that off of our servers running in the Amazon EC2 cloud. Or you could go along to the products, select the downloads, click on BBJ and Barista, and there's our buoy BBJ download app. And if you check the box for demos, either the second last one that shows demos or the last one that includes add-on software, and you download the product, you can run it off of your own desktop machine and see that sample code in action. So let's take your questions.